previously that to maximize the area for a given perimeter, the best shape to have is a shape where the length and the width are equal. So what shape is this? Well, this would be a square. And in this case, the length and the width are equal. So we could say length and length if we wanted to, or width and width. So why is this true? Why do we get a maximum amount of area when we have a square? So let's write up a couple of equations here and make some sense of this. So in general, the area of a rectangle is length times width. And the perimeter is 2 times the length plus 2 times the width. So if we're trying to maximize the area, we're trying to get as much area as we can for a given length and width, for a given perimeter, it could look something like this. So say our perimeter is 100. Then we're often trying to find one of our dimensions, say the length, given the width. And it's helpful to isolate that variable so we have 100 divided by 2 is 50. 2w divided by 2 is 1w, and it was negative, so negative w. So we would have the length is 50 minus w if the perimeter was equal to 100. Now if we use this information to write an equation for the area is equal to length times width. Well, we know that the length is 50 minus the width, so we could actually put that in. 50 minus the width times the width. So this would be an equation for the area. We're trying to get the biggest area value possible. So some of this isolating is a little bit above grade 9 math, but it's sometimes nice to see something that's a bit more challenging. So a lot of times what we've done is we've picked different W values and figured out what the length would be, and then calculated the area, found all the different values for the area to figure out the biggest area. So that works out nice, but we could also try graphing it. So this is a little bit new. We had 50 minus W times W. Okay, so notice that the graphing software did not like that I used a W. It's assuming that the W is for something else, and it doesn't know what to do, and it says it's invalid. All we have to do is replace our W's with X's, because that's what the graphing software is expecting a variable to be, and try again. And they graphed it for us. Now, this is kind of hard to see. Where is it? I see this little green line and then it's gone. So if we zoom out, and keep zooming out, usually I'm able to drag, oh, I got it right here. Oh, that little arrow showed up and then there it is. I can scrunch down just the y-axis. Okay, so what does this graph represent? So W was the width. If we have a width of 10, then the area would be 40. Okay? if we have a width of 20, then the area would be 600. Remember that if we had a width of 10, we could figure out the length and we could multiply the length and the width to get the area. Okay? And if we had a width of 30, we could figure out the length, multiply it, and get 60. Okay. Somewhere in the middle here, let's see if I can drag this out a little bit. Somewhere in the middle, the area values went from 0, 100, 200, 250, 300, all the way up to something above 600, and that's the maximum area. So they're saying the maximum area happens when the width is equal to 25. So if we go back to our little question here, it's saying that we need to have a width of 25. So our length is 50 minus the width. 50 minus 25 is 25. So if we have a width of 25 and a length of 25, what shape is this? A square. So the maximum area happens when it's a square. So a regular rectangle, if you're trying to maximize the area, you just need to have the length and the width equal. You need to make it a square. A square maximizes the area. Now, there could be a different situation where you only have 3 sides of the rectangle to deal with, in which case maybe there's a river on the other side or something else, some kind of structure. So in this case we have length and width, which means the perimeter formula would be different, the whole equation would be different, and we would end up with a completely different result. This idea that you maximize area by using a square is only true when you're working with a rectangular shape and you have all 4 sides, perimeter around all 4 sides.